PNSQC 2021 attendees. My name is Evan Masters, and today I will be speaking about how to bring stakeholders together through modeling. A little bit about me. I'm in Spokane, Washington. I've lived here all my life. I've been in software quality assurance since 2010 when I began my career with the company I work for called Critical Logic. I started out as a software quality assurance analyst specializing in what's called model-based testing, which I'll talk about a little bit later. My current role, I'm our customer success manager and product owner of a modeling tool that we develop called IQM Studio, and I'll actually show that a little bit later, just briefly as well. My background, I have a Bachelor of Science degree in physics and an MBA. I'm also a certified Scrum Master and am SAFe certified. And just as a side note, I'm also an adjunct professor of business ethics at a small private university here in Spokane called Gonzaga. If you watch college basketball at all, you've probably heard of Gonzaga. If not, you've probably never heard of Gonzaga. So what am I going to talk about today? Well, a few things. The first thing I'm going to talk about is just what I mean when I say models. When I say bringing stakeholders together through modeling, what do I mean when I say a model, and why they're good, when they're good, and that's very important, and I'll talk about that in a second as well. We'll talk about some different types of models and benefits of using different types of models, what we can do with models when we create them, because it turns out we can do some really exciting things. And then I'll talk about even more exciting things we could do with models. Some of you may be familiar with some of the things we can do. Others, this might be new to you. So when I talk about models, I really mean, well, models and more specifically diagrams, and I'll get into that distinction later, are really just pictures. Right? Like any picture, from the back of a napkin drawing to a formal UML diagram, like some of the ones that I'm showing on the screen now. But really, when I say model, I just mean a picture. And there are many different types of models, and each serves a unique purpose or introduces a new way to view information. So, why are models good? The first thing I like to call out is they help develop what I call a common understanding of the requirements. And really what I mean when I say a common understanding of the requirements is a common understanding of what the system that is being built should do. That's one of the things that models are really, really good for. Now you might say, Evan, wait, that's what specs are for, right? Or user stories, or the business requirements, anything like that. And yes, that is what they're for, no doubt. Here's the thing, though, about that. A recent study showed that nearly 80% of software defects originate in the requirement elicitation and design stages of the SDLC. 80% of defects come from the specs. So yes, specs are designed to describe what the system that is being built should do, but they don't always do a good job at that. Why is that? Well, it turns out there's a number of reasons. The first, and this is very common, much more common than a lot of people realize, is that the business doesn't truly understand the need of the system to be built. They don't know what they need the system to do, or they can't fully articulate it, whether it's, they just don't have a clear understanding of it, or it's a little bit too technical for them, or they just don't know. There's a lot of times when the business doesn't understand their true need, and that makes it very difficult to develop something that they're going to accept at the end of the day if they don't even know what they need. And then oftentimes important functions or big parts of the design are ignored or omitted. They'll say, well, we'll cross that bridge when we get there, or let's just get this piece of it done and then I'll decide on something else later, or we'll just leave it up to development to figure it out. And then development does that, and then the business doesn't accept it. They say, well, yeah, and I know I left this up to you and you gave me X, but really what I wanted is Z. So can you go back and change that for me? That happens all the time. Another thing that happens with these specs, and this is just because of the way the English language is it's just inherently ambiguous. The English language is inherently ambiguous. There's a quote that goes something like, English isn't really a language. It's three languages smashed together, masquerading as a language, something like that. And this is probably true of other languages as well. I only speak English, so I can only speak to English as being ambiguous, but I would not at all be surprised if there's inherent ambiguity in other languages as well. For example, the word biweekly. If you look up the word biweekly, the definition is it can mean twice a week or it can mean every other week. What's the point of a word that when you use it, you have to define what you mean by it? You have to say, well, we're going to do this biweekly, and by biweekly, I mean twice a week. Why not just say twice a week? So if you put the word biweekly in a spec, that's inherently ambiguous, and it can be interpreted either way. Both are correct, but you only mean it in one way. Another thing that can happen with specs, written specs, is they can be what I call lost in translation. And when I say lost in translation, I mean converting the need that is written in business terms and business vernacular to the development team who speaks a much more technical language. So that translation from business to development with a written spec can lead to different understandings, different interpretations of the same specification. So, are all specs bad then? No. And I want to be really clear here. I am not at all saying that all written specs are bad. That is not the case. Whoever wrote the spec for the Zune probably wrote a bad spec. We all know how terrible that thing was. Actually, hopefully, maybe some of us by this point have never heard of the Zune because it just faded from existence because it was so terrible. But my point is no one sets out to author a bad spec, right? More commonly what happens is people will set out to describe their need and they'll put a lot of effort into it and they'll put together something that they feel is very clear, very complete, very unambiguous that they think they can hand off to a development team for, to be implemented. And they're gonna, it's self-satisfying or self-serving, right? To put the work into putting together a good spec. What happens though is what's clear to one person, the person who authors it, they have so many thoughts, so much context backing that up that doesn't ever make it into the spec. So that when they hand it to another person, it's not clear, it's not complete, it is ambiguous. So no one sets out to author a bad spec or to be intentionally ambiguous, but despite our best intentions, those things still happen. So for example, I was talking with my boss a little while ago, and my boss is one of the smartest men I've ever met, and he and I see eye to eye on a lot. We're very effective at communicating with each other. But in this one specific instance, I was talking with him on a Monday about a customer that we had, and I told him that I had a meeting with the customer next Thursday. To me, that very clearly meant the Thursday of the following week. To me, next Thursday means you go to the next week and then go to that day, next Thursday. He interpreted it as the Thursday of the current week because it would be the next Thursday that we encountered. So even though me saying, hey, Bob, I'm meeting with the customer next Thursday was a very clear, complete, unambiguous statement from my mind, or in my mind, Bob was able to interpret it a different way, and we had to have a discussion and a clarification, even with that one simple statement. So I want to take a moment to recognize, too, and to reiterate, no, not all specs are bad. There are lots of good specs out there. I am not advocating that models should replace specs. I'm saying that we should use models to augment the specs, make them that much better, bring another design element, another artifact into the design process to make the SDLC that much better. So some of the things we can do is use things like formal structured language in our specifications, data dictionaries, for example, so that we have very precise definitions of things, of the words that we use in the spec. So in my example, instead of saying next Thursday, I could have said Thursday, October 14th, 2021. There is only one way to interpret that date. That is the formal structured way to talk about a date in a clear, complete, unambiguous way. So not all specs are bad. All right, switching gears a little bit now and talking about the different types of models. And I should say real fast here too that the models that I'm going to be talking about and that I'm familiar with are models that are and diagrams that are defined by UML standards, the Unified Modeling Language, which is a standard put together and maintained by the Object Modeling Group, or the OMG. And the OMG and the UML standard says or defines two broad categories of diagrams. We have behavioral diagrams and structural diagrams, sometimes referred to as dynamic and static, respectively. Behavioral diagrams are a way to develop a view of the system in motion, is how I like to think about it, the flow of the system in motion. Structural or static diagrams, on the other hand, define the unchanging elements of the system, the things that are in place that stay static. So some different types of behavioral diagrams are activity diagrams, for example. Lots of people are familiar with activity diagrams, and they're similar to like a process flow diagram. Those are, pretty intuitive to a lot of folks, both in the business, well, I will say in the business, QA, and dev side. Another type is what's called a use case diagram, or what I'm, oh, sorry, that's the wrong one. Those are out of order. A use case diagram here, or what I've gotten in the habit of calling a function map that defines the different functions of a system and the actors who can invoke them. And then finally, we've got a state machine or state transition diagram, sometimes they're called. Those are all types of behavioral diagrams. On the structural diagrams, we have things like class diagrams. These are incredibly useful. I've actually got two different views of class diagrams here. One that has some attributes to the classes here, and then one that's just the classes themselves. Both are very useful views to develop. And then another type of structural diagram is what's called a component diagram, and that's pretty self-descriptive there. My personal favorite type of diagram, though, is one that probably a lot of you haven't heard of, maybe none of you have heard of actually, which is called a cause-effect diagram, or CEM, or SEM, we call them sometimes, and cause-effect model. And this is a behavioral type of diagram, and I'll get into these a little bit more, and I'm going to do a Zoom room right after this, so if you want to see more about these cause-effect diagrams, come to my Zoom room and I will be happy to showcase it for you. But cause-effect diagrams are awesome. They let you use Boolean logic and statements and or statements, that sort of thing, and really describe the system in a way that we say you can synthesize information from every level into a cause-effect diagram and give you your sort of one source of truth in a cause-effect diagram. So what are some of the benefits? Like, why should we be using models? I advocated earlier for using models to augment our specs. Well, why? What are the benefits of that? If we do it in the earlier stages of the SDLC, sort of the design and planning stages, one of the things that modeling is gonna do for us is help us to develop a very clear understanding of the need to be met in a way that a written spec can't do by itself. It's gonna give you that crystal clear view of what the need is and how the solution is gonna meet that need. Another thing that it'll do related to that is accelerate the design process, because we're not trying to describe everything using words. We're going to, take 5 minutes and draw a picture instead of 50 minutes to author a spec or an additional part of the spec. We're going to be much more efficient with our time using modeling. It also allows questions to be brought up and discussed, and oftentimes thought through all the way and resolved, answered those questions in real time in the context of the model, showing in the model where there's ambiguity or an incomplete section of the spec or contradictory statements, something like that. And related to that, we can identify and draw the curtains open to find the ambiguity inherent to the spec. Whether that's unclear language or just again, a missing piece of the spec, whatever the case may be. These are all some of the benefits that we're going to get by developing models early on in the SDLC. At later stages, we're going to continue to develop, or if we continue to develop models, we're going to continue to see benefits. Like in the early stages, if we're modeling later in the SDLC, we're going to have a very clear, crystal clear sense of how the solution will be implemented. We're also going to have another chance to ask and answer questions that come up, again, in the context of the model. We're going to use those model review sessions to clarify any confusion that may exist, whether, if that's after the product has been delivered or a piece of the product has been delivered, we can say, is this how it's supposed to be? Like this, if we model it out, this is what it will look like. Is that the intended behavior or not? It also allows us to fill in gaps in the spec, right? So if you've got, and this is kind of what I was referring to when I'm saying not all specs are bad. I've seen lots of really good specs that seem solid when, at first glance, and they look ready to hand over to development team. But when we model them out, we're going to find, oh, there's this thing that we didn't see, even though we did a review and a sign off on the spec, we didn't see it until we saw it in the model, until the model brought it to light for us. So that's something that models are excellent at. It also allows us to take these very, very complex specifications, and because we're visualizing them, it really makes it a lot more simple. It takes this complex thing and makes it simple, which is a very, very powerful thing. And I couldn't find a picture of a string that was straight, so I drew that. And it looks, less than good, but I hope it conveys the right message, that we're going to take this messy spec and streamline it using a diagram or a model. And more on that distinction later, by the way, if I haven't said that, between a model and a diagram. And this is really where my experience lies, is there are some types of models, like a cause-effect model, that let you automatically generate reports and tests and all kinds of cool things, scripts, even automation scripts from the model, which is just huge. And depending on when you create the models, earlier or later in the design or in the SDLC, you can actually, send the spec and some of these artifacts, test cases, for example, that come out of the model. You can send that with the spec to the dev team so that they just have an extra design artifact to work from, not expecting development to run the tests, but they're going to know what QA is going to test when the spec is delivered, or when the product is delivered. So who's using models? Like, is anything that I'm saying true? Like, is there any empirical proof to any of this stuff, right? Well, it turns out the answer is yes. There is what's called the Model-Based Testing User Survey. And this is put out periodically, and I think it goes back to 2008 or 2010, somewhere in that range. And the latest edition of this survey just came out in 2019. put together by Anne Kramer and Bruno Lagarde, both members of the German testing board. So modeling and model-based testing is a lot bigger in Europe than it is in the US or other parts of the world right now. From my experience, kind of continental Europe is the hub of the model-based testing world. So I bring this up, this model-based testing user survey, because they ask a series of questions. It's 36 or so questions. One of them that they ask is, what are your expectations on implementing modeling and a model-based testing approach? Over 65% of respondents said, we wish to improve communication between stakeholders. Or another way to say that is they want to bring stakeholders together through modeling. So 65% of the people that responded to their survey had that as one of their expectations. The survey goes on to ask, from your current experience, does model-based testing fulfill those expectations? A staggering 75% of respondents answered yes or partly to that question. 46% said yes, 29% said partly. And I would venture an educated guess and say that of the 29% that said partly, probably just needed a bit more coaching, or some coaching, maybe they didn't get any, on how to effectively use the models or know which type of models to use to fulfill that expectation of improving communication between stakeholders. So yes, people are using this, and model-based testing in general, modeling and model-based testing in general, does provide the benefits that I'm talking about here. So let me talk now about some of the examples I have from my own personal experience. The first company I'll talk about is a company called General Dynamics. They're a Department of Defense contractor, and it was actually the first model-based testing project that I worked on. And the project had over 2,500 requirements to define the two core systems that were being developed and that we were responsible for assuring quality with. And it was all just a huge list of requirements in DOORS, which is IBM's requirement management system. Just a gigantic list of 2,500 requirements. And we would get periodic extracts of that in the form of like this, I forget, 500-page Word document. And they said, test it using these. Make sure that, what's getting delivered is what's in the spec here. And that was like just impossible, right? With going based on the spec alone. That is just such an enormous amount of information. And General Dynamics at the time was tasked by the Navy, they were working for the Navy, to improve the quality of their systems. These were mission and life critical systems. Letting defects into production was not an option. So we took a modeling approach and we developed cause-effect models of their requirements and then used model-based testing to generate tests from the information that we put in the model. And it was a huge benefit, huge benefit to the project. Quality went up, testing costs actually went down, and they were, it was a very successful project. And that worked because with a huge list of requirements like that, very technical requirements, it was very easy. We noticed quite often where they would define the way the system should work given a set of conditions in requirement X, but then requirement Q way down the line would have the same conditions but a different system behavior, different outcome. And you couldn't see that in the spec just because it was such a, just a huge list of words, long, wall of words. Putting that in the model brought all those combinations to light, and we could show instances where, hey, you don't have this combination of system attributes defined. We don't know what happens here. Or you've got it defined twice, but it's saying two different things given the same conditions, which should actually happen. The next I'll talk about is a company called Sun Microsystems, now Oracle. They were acquired by Oracle. They had a system they called their configurator, which was the system that allowed their salespeople to see the offerings they sold, like server hardware and software. And the configurator would let them display only valid combinations, like, this case can have these hard drives and this processor and motherboard and all that stuff. And they had 60,000 business rules to define their system. And because of the rate of change of software and hardware, about a quarter, 25% of those 60,000 rules would change every month. By modeling the rules, beginning with the ones that were changing, the impact of that change could be anticipated and communicated to the stakeholders much more effectively. As a result, the rate of release doubled, and they went from releasing twice a month to once a month, and multiple zero defect releases were attained, which is not something they'd been able to do before. Next, I'll talk about a company called Salesforce.com, another large, pretty much a household name. And in the height of their boom, they had no consistent way for requirements to be elicited and documented. So they had BAs doing the work, business analysts doing the work. They just didn't have a consistent way of doing it. Unsurprisingly, this led to missed requirements or incorrectly interpreted or implemented requirements. So again, by modeling the requirements, we brought in a clear, consistent fashion for the elicitation process to happen. And the result was elicitation effort decreased by half. And the quality of the software delivered increased. That gave their sales folks confidence in in their system, and they were able to much more effectively use the system. And then finally, we had a customer that I can't name due to NDA, they were charged with centralizing and making veterans' medical records available nationwide, specifically the allergies to medication allergies, and the adverse effects that they had from those medications. So the vendor in charge of developing the system took ownership of the, quote, complete set of requirements from the VA. And by the time they did, they realized that that complete set was anything but. And just for political reasons, going back to the VA and saying, hey, these aren't complete, can you finish these so that we can implement them, was not an option. So the first thing we did was draw pictures. We created, in that instance, we used use case diagrams, or again, what I've gotten in the habit of calling function maps, to identify exactly where the functionality wasn't defined, or even functions that were missing altogether. Once we'd done that, we could go back to the VA and ask them just those specific questions using the models to show exactly where we needed more of their input. And that was acceptable to the VA. From there, we used cause-effect models, and this actually is a real cause-effect diagram from that project, to automatically generate tests from the model. Our tool, which is what I'm showing here, IQM Studio, has a test generation algorithm that lets you just click a button and it'll generate tests from the information you put in the diagram. So you can see here, this particular diagram identified 124 variations and was able to create an optimized test set of just 6 tests or scenarios to cover all of those variations. And then we were able to hand the spec and the tests, over to the development team. And we had just about every delivery that they gave was accepted as is. So I mentioned earlier the distinction between a model and a diagram. And I've kind of been using them interchangeably to this point, but it is worthwhile to talk about the distinction a little bit. The way I like to think about this is a model is an abstract representation of something, a system, for example, where everything is defined exactly once. Every object or component that makes up that thing is defined once and only once, and is put in some kind of a repository. So that's what I think of when I think of a model. A diagram is a specific view of that model where you're referencing the elements of the model. You're not redefining, here, database manager. I'm not going to redefine it. I'm going to reference my one and only instance of database manager in this diagram. And then I'm able to create the view that I'm interested in of the model in a diagram. So we build the diagram on the left using the elements in our model, or sorry, in the right, using the elements of our model and creating the view we're interested in. I bring that up now because there are certain types of models that let you do even more cool things. So those are some of the cool things you can do with models. Here's even more cool things you can do with certain types of models. One of the things that we can do is associate the model to an automation framework, which is a type of model itself in terms of being a repository of things that define our system. And my experience in doing that, relating a model to an automation framework, leverages what are called keywords, also known as action words, or you might have heard scriptless testing. That's what I mean when I say keywords. And keywords are a human-readable term that defines an action on an object with specific parameters that links to a human test action and an automation code, or a chunk of automation code. And this is really cool because what I'm saying in other words is an automation framework using keywords lets stakeholders of any kind, any technical level, develop automated tests. So business analysts or users of the system can use keywords because they're human readable. They can author a keyword level script, and I'll show that in just a second. And that gets automatically turned into an automation script using this framework. So on the screen here, I have verify the balance for the account on the My Account screen matches the latest statement balance. Verify is the keyword. Balance for the account on the My Account screen is the object. And statement balance is the parameter. We just have to pass those three things in, and we can develop an automation test. And this is what it would look like. So this is a script level test or a keyword level test. So the keywords are in red, and the parameters are also included here. And so when we say something like start the demo app, that gets converted into this chunk of code. Verify the current window as login corresponds to this chunk of code, so on and so forth. So what happens is that we'll have keyword level tests that again are very descriptive and human readable. And because the keywords are linked to the automation framework, these tests result in a fully functional, syntactically correct automated test that you can feed into your automation tool. This is a so that's the sort of thing you can do. The even more cool things that you can do with models. So in conclusion, there are tons of different types of models out there. Again, from back of a napkin to a very well-defined, formal, structured UML diagram. Lots of different types of models out there to use. No one sets out to write a bad spec, but bad specs still get written. 80% of specs come from the requirement elicitation and design phase. Modeling brings stakeholders together and augments our specs. Like they're symbiotic. They should be always together, a spec and a model, a spec and a model. And you can do a lot with models. All the benefits that I talked about, some of you maybe have realized those yourself, but taking it to the ultimate level of creating those types of models that we can use to do model-based testing, which results in very efficient, very effective testing, giving us a high level of quality assurance, not just quality control, and all the way to creating those automation scripts so you can use that as your regression test library and focus your QA activities on the things that are valuable and worth the most amount of your time. Thank you.
Okay, guys, I'm realizing I didn't leave much time for questions, and I haven't really been paying attention to the chat too much. Excuse me, are we okay to stay on here? Or if not, I am doing my Zoom room right afterwards. Folks can bounce over there.
Evan, if you don't mind, place the room information in the chat screen, and I will, continue the conversation with you for a few minutes and give a chance for anyone that want to leave to leave. We are entering into the kind of a break period. So, and there is a presentation there that's going to start shortly. So, so with that said, Evan, would you mind? We'll use a few minutes. Feel free to answer any questions that you have. One question that's being asked is, will the slides of this presentation be available? And I can answer that for Evan in that these are all linked on Evan's PNSQC webpage. So that will be available soon. And so Evan, please take it and answer maybe a question or two that you would like to do.
Yeah, sure. So May is asking about a link to the survey. Yeah, if you look at my paper, my corresponding paper to this, I've got all the references for everything I used to put this together in there, including the link to that survey. Let's see.
One question I had, and obviously many people use different types of models and diagrams, and it's very common for business analysts to use flowcharts or swim lane diagrams. Maybe it's helpful to the audience to hear how you differentiate between the diagram you use and those diagrams used by business analysts.
Yeah, that's a good question. And, I advocate for all different types of models to be used by all different roles, just getting that level of familiarity. And the more people that are using the diagrams, the more it kind of becomes the default. So yeah, with a lot of people, in my experience at least, they'll use terms like activity diagram and a flow chart kind of interchangeably. But yeah, I'm working with a group right now where we're taking their business analysts and who are developing these activity diagrams, or they call them workflows, that have things like swim lanes in them that define them, various roles, like what each role does, in their flow. But we're finding that there's one activity will say something like, fill out this form or something like that. But then when we actually start to drill into that piece of the diagram, that involves like opening 3 other systems downstream and excuse me, certain conditions have to be in place for that form to even be available, things like that. So we're starting with the high level workflow, drilling down deep into these activities in cause effect diagrams. We're using cause effect here. It's incredibly useful for that. And shedding light. And really what we're doing is developing, we use the term, you guys may have heard this before, a single source of truth. Like the cause effect diagrams are going to be the place that encapsulates everything, and including all the information from the workflows, but more importantly, everything that's not in the workflows. We're synthesizing all of that together.
Thank you, Evans. And we have 1 more minute, and literally, and a question from Jessica. It says, there is a perception at times that diagrams modeling are not a good use of time and end up imposing unnecessary limitation on development efforts. What's just one way to counter a statement like this? And you literally just 1 minute.
Yeah, great question, Jessica. We get this all the time. I will say you never set out to model everything. Like there are certain things that's absolutely correct. You shouldn't model everything, but there are tactics that you can use to identify, like we always do that analysis first. Where does it make sense to model? Where are we going to get the most value out of modeling? Focus on that. And then if your time allows, you can backfill later. So that's my 60 seconds or less response to that. But great, very good question.